So for this puzzle, I bought a set of these light up, flickering, moving flame candles, and I basically gutted it. So when you take it apart, the inside looks like this, and there is an LED here with 2 wires coming out, and you can just reuse that same LED that's in it, but you'll need to cut all the wires off and cut off this base and remove the flame. So after I did that, I made my own setup to hold the inductive proximity sensor. So I cut off the top of the candle insert, made a 3D printed white insert on top of it so that you can't see what's going on as well underneath. I hooked up a new 220 ohm resistor to the positive terminal of the LED that was already in it, and the other side's ground. And I 3D printed a little base here for the inductive proximity sensor inside, which is screwed on there. So the top of this is the part of the inductive proximity sensor that picks up anything metal that touches it. So in making this, I had to make sure that nothing else in the room could fit inside of this, because if you put any metal piece in there, it would pick it up and trigger the stepper motor. So you can see here the flame, I just pulled it off of the top. I think I cut the metal, and I used a straw filled with, like a transparent straw filled with some putty, and on the bottom of it I just put a thumbtack on it. So once that is inserted, it actually lights up the LED too, so it lets the player know that something has been accomplished. And that kind of tells them that something is happening, and there's a suspenseful moment when they can hear the stepper motor whirring and hear something behind this curtain, and out pops the creepy little doll head. So behind this curtain is a mess of tape, electronics, wires. It's not very pretty because no one can see it when playing the room, so I wasn't worried about making it pretty. But we've got an Arduino Nano here, and I've taped over some of the lights just so they can't show through when it's dark in here. And a stepper motor up here that has a pulley insert that I 3D printed on top of it. And I used just a regular box from Amazon and 3D printed an insert to hold the stepper motor as well. And then we have the stepper motor driver and the battery, which is connected to the inductive proximity sensor. So here's the wiring diagram for this puzzle. We have the stepper motor, which is connected to the motor driver. We have ion 1, 2, 3, and 4 connected to pins 8, 9, 10, and 11. Our battery high voltage connects directly to the inductive proximity sensor, and the wires on the sensor are not the standard convention. So with these sensors, brown is the positive connection, blue is ground, and black is the communication with the Arduino. So the black wire is the one that's connected directly to the Arduino. Here we have our LED wired up separately with a 220 ohm resistor. Here's the code for running this puzzle. So the first thing is to include the stepper motor library. Set the speed. 13 is the fastest I could get it to rotate with the weight that I had on it, but you might be able to experiment with a higher speed. Initialize the stepper motors and the pins. While it's 0 and the flame is not in it, it is in this loop where it first starts with pulling the pulley up into the set position where it's hidden behind the curtain. The LED is off, and it continuously checks every second
the value again. And if that value switches to 1, meaning a piece of metal has touched the proximity sensor, it then goes into this loop, which releases the pulley and it drops down. I had to work with this value based on my own length of ribbon that I used and to where I wanted it, and found that this was the right number for the length I wanted. And while the while the flame is in there, it still just continuously checks if it has been removed or not. If it hasn't been removed, it just halts the motor and hangs there.